Hello class, today you're going to work through some quadratic word problems. The goal of today's lesson is for you to be able to solve quadratic application problems using what you know about quadratics in vertex form, in factored form, and in standard form. Okay, so this is going to be the homework for today. You've seen this before. We've talked about this last time. It's just the idea that there are some key words that you might hear in word problems that will help you decide what form you need to be working on and what quadratic feature. For example, if you hear the words maximum, minimum, largest, least, or the smallest, you're always thinking back to the idea that in a quadratic, the quadratic graph is always in a parabolic shape where you'll have a max or a minimum point, which is right here, right? And so you're looking for the vertex. That might mean you have to find the axis of symmetry. That might mean you're talking about the y value in particular of the vertex. Okay, so these are typically when you're asking for the maximum or minimum amount, they're always asking about the y value of the vertex. Okay, if they say when does it happen, that's when you're looking for the x value of the vertex. Okay, so this is for the actual amount. And then if you're saying when, then they're talking about the x value of the vertex. Okay. When they're asking you to solve for a value or solve the quadratic or find the zeros, they're always asking you for like, when does it hit the ground? They're saying the x-intercept. Okay, so that's when you would start looking for the factored form and setting up the equation. You could either factor it, you could use the quadratic formula, which you now know, or you can graph it and then look at when it actually crosses the x-axis. Okay. If they're asking you for when did it start, what was the initial amount, they're asking you for the y-intercept. So when does the graph cross the y-axis? When did it begin monitoring? So you would normally plug in x is 0 for the equation and solve for the y. And just to refresh your memory over here, I have for you is just kind of how to go from one to the other. So standard form is like the basic form. It gives you just the y-intercept, so that's the c value, because if you plug in 0 for x in the rest of the equation, all you're left with is the c value. Okay, that's your starting height, your starting price, your initial amount, etc. If you want to go to vertex form, you are going to complete the square, right? Yes, you can use the shortcut, but as you notice, you also need to know how to complete the square. So therefore, you'll have to figure out your h and your k in your vertex form. That's your vertex. What does that signify? Well, the h is your x value vertex. That tells you when it does happen. When does the maximum, when does the minimum happen? At what time? How many items to reach the max? Those are the keywords you'll be reading. To find the k, which is the y value of the vertex, they're asking you for the optimal amount, the max, the min, talking about the maximum height, the minimum height, the maximum profit, the maximum money, the maximum area. These are the commonly what you'll see in these word problems. And then what happens if they wanted the initial value? Yes, you could go back into standard form by expanding and distributing, or you could just plug in x is 0, solve for it. It's not k, just you have to plug it in and figure out what the y-intercept is by plugging in 0. Okay, there's no shortcut to finding the c from vertex form. All right, what if you need to find the x-intercepts? Well, we know factoring from unit 3, so you go into factored form, you find your r and your s's. Remember, it's the opposite. Or if there's a number in front of the x, you're going to have to take each bracket and set it equal to 0. The x-intercepts in word problems are things like solve the quadratic. What's the break-even point? What are the zeros? When does something land? When, like, how far does something travel? Or what are the roots of the quadratic? And that's when you're looking for the x-intercepts. But we have now learned a new tool called the quadratic formula, which takes a standard form and just solves for the x-intercepts. It doesn't give you the factor form. It just goes straight and tells you your x-intercept. So that's another way to go and find that. All right. Okay, so just quickly, here's an example. You'll see this in my content library, a word problem I've worked out. So here we have a rectangular park that measures 100 meters by 60 meters. They want to create a path of a constant width, so the same width around the perimeter of this park. So they want to pave around the perimeter of the park. The mayor wants to ensure that the park does not reduce the area of the grass by more than 10% because they want it to be very green. So they won't want to take over all the grassy area. So the question is, what is the maximum allowable width of the path, round to the nearest tenth of a meter. Maximum should signify to your mind, I need the vertex. What part of the vertex? Well, let's find out, but we need to set our variable. So if this is the park right here, you want a width. So that means that we're going to cut into the park this way. So we don't know how wide we are going to create the path. That's part of the question. It says how wide of the path is it going to be? So we're going to call that width of the pathway x, and that's what you see here. And whatever is here is going to be the same here, it's going to be the same here, and it's going to be the same distance here. So that's the width of the pathway. So now if I think about that, the question said that I can't have the area of the grass be reduced to more than 10%. Well, the original area of the rectangle park is 6,000, 60 times 100. So therefore, if I can't have any more than 10%, that means I'm only doing 90%, which you have to multiply by doing 0.9. So 0.9 of 6,000 means the area that I can only, like this area in the middle, has to be a maximum of 5,400 meters squared. So I need to make sure that this space in between, green space here, in between has to be no less than 5,400. Okay, well then therefore, what is the dimension of this green to figure out the area? It's also a rectangle. Well, the dimension of this rectangle is, if this initially was 60 meters, if this was 60 meters, I'm going to cut into it by a pathway that's x in length this way, correct? This is length of x. And this side is going to be a length of x. So the leftover dimension in green is 60 minus 2x, right? 60 minus 2 of the x's. And then similarly, this length here, that was initially 100 meters, is now going to be reduced by 1x on this side, 1x on this side. So the dimension of the inside green rectangle is 100 minus 2x. So I'm going to create an equation to make sure that this green rectangle is no less than 5,400. So I'm going to let x represent the width of the path. Remember, we always have to write our let statements. I'm going to say that the area is 5,400 meters squared equals, and then we said the dimension is 100 minus 2x here. And we find the area, we multiply by the width, which is 60 minus 2x here. And then it's a quadratic equation. I'm going to distribute, and I just simplify, and now I'm left with 5,400 equals 6,000 minus 320x plus 4x squared. Bring everything to one side because I'm solving the equation. So I always have to make sure when I'm solving the equation that this side is always equal to 0, okay? So then I put 4x squared minus 320x plus 6,000 minus 540. So the end quadratic equation I have is this 0 equals 4x squared minus 320x plus 600. I want to find out, when does this happen? So I'm actually trying to find out the x value, the x-intercept in the case. But the x-intercept is not talking about the x-axis. When I initially set the equation as 5,400, I'm actually trying to find out, when does this quadratic equation hit 5,400? That's the value over here. So imagine if there was an imaginary x-axis at 5,400, when does the quadratic hit those 2 points? So that's really I'm solving for, is the x-intercept at 5,400, if that makes sense. Not the vertex like you would normally have thought, because we said maximum. So to do that, I'm going to use the quadratic formula. Yes, you could factor if you could try, but it turns out it's not factorable. So I would use a quadratic formula, rewrite it, plug in, this is my a value, b value, c value, plug it all in. I get two values. I get x equals 78.1 and x equals 1.9. So both of these would get me 5,400, but I want the smallest pathway so that I'm not taking over the whole rectangle. So it turns out it's going to be 1.9 meters is the width of my path. Okay, otherwise you're going to get the opposite side. All right. One more problem just to make sure. We've kind of did this one, but I just want to go over it again because this one I found some of you might need another look over. One leg of the right triangle is 1 centimeter longer than the other leg. So here's my right angle triangle. I'm going to call one length x. Oops, I forgot to write my let statement. So let x represent one leg of the triangle. Okay, so then if this is x, one other side of the legs is x plus 1. Then it says the length of the hypotenuse, the longest side, the one across the 90, is 9 centimeters, so it's going to be x plus 9. Now I have 3 side length expressions. I know that they are related by the Pythagorean theorem. So c squared equals a squared plus b squared. I'm going to plug in x plus 9 as my c, then I have to square it. I'm going to plug in my x plus 1 as my a, I got to square that. And then I'm going to plug in my x as my b, square that one. I simplify the expression I end up with here. I'm going to solve the equation, which means I'm going to factor and solve for my x values. So I got 20 and negative 4. Well, negative 4 is not a proper answer because that means that the length of this leg of the triangle is negative 4 centimeters. That doesn't make sense. So that one gets canceled. So therefore, this leg length is 20 centimeters. B is 20 centimeters long. The A side here, the x plus 1, is 20 plus 1, so that's 21 centimeters. And the hypotenuse, which is x plus 9, that's going to be 29 centimeters. So my triangle dimensions are 20 by 21 by 29 centimeters. All right, so hopefully that gave you some ideas of how to solve some quadratic word problems. Now I want to see you do that on app.formative. So make sure you go to your app.formative.com, log in with your student account, and I want to see you complete all these. I know this looks like there's 6, but they're really quick, and I just want to make sure that you are understanding and having a good understanding of quadratic so far and word problems. So please go do that now, and then when you're done, I want you to go move this over here into your OneNote, and you should now have the 5.6 homework, and you just have to complete the essential homework, and that is due for you. I'm going to look for it on Tuesday. I know we don't have class, but hopefully you can get all done today. There's only 1, 2, 3, 4, 5, 6 word problems for you to try out. And then if you need to, there is the solutions mapped out for you just so that you have some full solutions for you to look at. I've also sent out here the review. This is review. This is some tips on how to study. Your test is in a week and a bit, so make sure you try to start reviewing and ask questions if you have any. Come see me in extra help during Wednesdays, or just reach out and we can try to find an alternative time. There's also a practice test, so you could try this one out as well. Maybe do it closer to the test and see if you can understand all these questions. The answers are also at the bottom, so you can just double check your practice test. All right, good luck and have fun and have a great weekend.